This is Professor Needing, and here we go again with Math 168. A wonderful fall day outside. This is section 2.4. This is Boxplots and Quantitative Categorical Reasoning. Use Boxplots when we have one quantitative and one categorical relationship. Again, you want your calculators, as you will probably for pretty much all sections this point forward. So let's take a look at what we have this morning. This is a fairly short section, but just because it's short doesn't mean it's not relative, and it is important to you. So how about I go away right now, and we'll get rid of my picture in just 1 second here. There we go. Move me over the side. So first of all, I'll let you look at me for a minute here while I shut that out. When we talk about a box plot and quantitative categorical relationships, we're talking about a range of values, for instance, maximum to minimum. And I showed you that previously on a calculator. And when you did a one number variable or one number statistic, for instance, I'll run a stat real fast and a calculate on a one variable statistic. I don't know what's in L2, but I'm going to run it. And remember that 5 number summary that we see at the end. 5, 4, 3, 2, 1. The minimum to the maximum, that's what we're talking about right now. We're talking about that range of values from, I was showing a range there. We're talking about that range of values from top to bottom. And that range is min-max. And the IQR is Q3 minus Q1. So again, back here, if I look at Q3, 68, and Q1, 17, then 68 minus 17 is referred to as my IQR, or my interquartile range. We're going to use the IQR rule for detecting some outliers today. Box plots, we're going to create some, and we're going to talk about the one quantitative and one categorical variables. All right, so let's see what we got here. So an outlier can be informally identified by looking at a plot. To be more precise, we use the IQR rule for detecting an outlier. So if we're looking at a piece of data and we see it, and let me see, what can I show you? I can show you a stat key. And inside stat key, if we run a box plot, so first of all, we have to choose one quantitative, one categorical. We got to find some data that maybe, this looks like it would have an outlier here. See this person right here, this 40 right here? That looks like it might be an outlier. So if I run a box plot, sure enough, all these asterisks are outlier data. And we're going to figure out how to calculate that outlier data today and how to figure out that these are actual outliers. Nice thing to know on a TI-84 is I can run a set of data and I can see if it has a outlier also. So for instance, let me look at my stat. Let me see what I have in here. Let's actually put something in here that's worth using. So first thing let's do is I'm going to clear second memory. I'm going to clear all my lists number 4. I'm going to make a bunch of stuff go away, and boom, done. I'm going to go to stat, and let's just play here for 1 second. Let's go to edit. Let's put some stuff into L1. So let's put 2, 2.1, 2.3, 2.5, 2.7, and 29. So 29 clearly is an outlier from the average set of data going on here between 2 and 2.7. So what does this look like when I graph it? Okay, well, my calculator will actually do a fairly good job of making a graph. So stay with me. Here we go. So first thing I'm going to do is I'm going to go to second. I'm going to go to y equal, which is called the stat plot. In the stat plot, I have 5 different stat plots. And I have an availability to turn off all, turn on all, or turn on and off individually. Right now, you can see number 1, 2, and 3 are off. 1, 2, and 3 are off. So I'm going to go into plot number 1. You want to make sure all of these are off. If they're not off, then go down to number 4 and plots off. So I'm going to go to number 1. I'm going to hit enter. Now, first thing I can do is turn it on. So where it's flashing is what it's going to select. And if you hit enter, it'll turn that plot on. I'm going to go downward. I'm going to scoot over 1, 2, 3, 4 to the one that looks like a little box and whisker with some dots on the outside of it. I'm going to hit enter. The data I put was in L1, so I'm in good shape there. So I'm good with everything here. I don't need to change anything else. Mine will go, the color is going to be blue. You can play with color if you feel like it, but blue is going to be me. Now, there's one other thing I have to do first. I have to make sure I have no equations in my calculator. So I need to go back to the y equal without the second y equal. I need to make sure all of these things are empty. So if there were a 2x sitting in here, I would have to, if there were a 2x sitting here, I'd have to get rid of all this stuff by clearing it all out here. Okay, once this is clear and once this little plot has been done and I've set up everything, hit the button that says zoom. You scroll all the way down, or you hit the number 9 that says zoom stat, because we're in statistics. And look at that compressed box right there with this outlier way out here. It's a terrible one. We got to go back. We got to edit this thing. This one's too far out. Let's go back to stat. Let's edit our data. 29 was a little extreme. Let's go to 9. Okay. Change that 29 to a 9. Now let's go back again. We already set it all up. All we got to do is go zoom 9. There we go. So there's my box and whisker, and you can see I got this dot laying out here. And if I hit trace, I'll see that that dot right there, there's my median, 2.4. There's my quartile 3, 2.7. And there's my X. And there is my 9 maximum, which is sitting way out there as an outlier. Now, what does it look like if it's not an outlier? Go back to stat. Go back to edit. Let's make it 2.9 instead of 9 in the normal range here. Let's go back to zoom. Let's go back to 9. And there's my box and whisker. The low number, minimum. And if I do a trace, right here, trace, I can see all these numbers. So start at the minimum. Minimum 2. Quartile 1 is 2.1. Remember, that's the lower median. Median number 2, or the median of the whole data set, 2.4. Quartile 3, 2.7. And the maximum, 2.9. If you want the interquartile range, take 2.7 and subtract 2.1 for 0.6. Very nice utility to know when you're working in this course. So let's keep going. So a IQR rule for detecting an outlier. The rule is that if something is truly an outlier, then it is smaller than Q1 by 1.5 multiplied by the IQR, and it is an outlier if it's greater than Q3 plus 1.5 times the IQR. Okay, well, let's look at that on a piece of paper real fast. So I have some value Q1, and I have some value Q3. Remember, this is the box, because we have tails coming out of here, out of Q1 and out of Q3. So the rule is, once you determine the IQR, remember the IQR is Q3 minus Q1. So let's say that our Q1 is 5, and let's say our Q3 is 7. 7 subtract 5 is 2. I have an IQR which is equal to 2. Now, look at the rule. The rule says 1.5 times the IQR subtracted and 1.5 times the IQR added. So when I go back, so I'm going to take my first rule here. I'm going to take number 5, which is my quartile 1. I'm going to subtract 1.5 times 2. Okay, well, 1.5 times 2 is 3. 5 minus 3 is 2. So that means for me, anything that goes below a 2 will become an outlier. If it goes below a 2, because 2 is my limit for IQR and for outlier range. I go to the top, 7 plus 1.5. It's always 1.5 times the IQR, 2, which was still 3. 7 plus 3 makes 10. That means I can go up to 10 until I become an IQR outrange piece of data. So to draw a box plot, it's just like I was just kind of showing you. It says draw a numerical appropriate scale for the data. The box will stretch from Q1 to Q3. We'll divide the box at the median lines, and we'll draw a line at each quartile to the most extreme data value, which is not an outlier. That's a big deal right there. I'm going to underline that. Draw a line from each quartile to the most extreme data value that is not an outlier. So if your maximum is actually an outlier, your box and whisker won't go to that value. So what does that mean in layman terms when we're actually making a drawing? So let's say that we have some data values. Let's say that we have a minimum, which is 2. We have a quartile 1, which is 4. We'll make this very symmetrical. We have a quartile 2, also known as the median, right? Which is, let's say 5. We have a quartile 3, and quartile 3 is 7, and we have a max, and we'll keep the max inside. We won't let it be an outlier, and we'd have to check it to see if it actually is an outlier. Let's just say that it's 8. So we'd make an appropriate scale that went from 2 to 8. So here's a 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I have an appropriate scale. Now I know that my 5-number summary has to include a 2. There's a 2. It has to include a 4. It has to include a 5. And it has to include a 7. Now I'm going to stop right there for a second because these 3 right here make the box. So right away, here's the box from the box and whisker. And here is the median. Oops, I'm a little low, I'm sorry. So again, the box comes around 4, 5, and 7. And here is the median because the median was 5. I still have to go out to 8. The tail goes to 8. The tail goes to 2. And here's the box and whisker. You can see that my data is a little skew right because this box is larger on the right, which tells me it's skew right, which means for us today that the mean will be shoved over somewhere towards the right of the median. It will be greater than 5, but yet at the same time less than 7. Probably somewhere around 6 if I did the actual mean right here. We found it. Matter of fact, why don't we just do that? I'll just take 2 plus 4, which is 6. 6 plus 5 plus 7 plus 8, that's 26. There are 5 pieces of data right there. And if I found that, it's 5.2, so it's definitely above 5. The 5-number summary we talked previously gives 25 percentile coordinates between the numbers. It breaks the box into 4 equal segments, and those 4 equal segments contain 25%. Even when we look at the box that I just got done drawing a minute ago, 25% of the data here, 25% here, 25% here, and 25% here. It doesn't matter how compacted or how spread out the box, it still holds always 25% of the data. The percentiles are corresponding to that. So if you are in the 10th percentile, you are somewhere here. If you are in the 99th percentile, you are somewhere here. Wiley question number 1. Match the 5-number summary with each of the following box plots. Okay, so all we really need to do here is just simply spread out our data and take a look at what we have. First of all, we have a 2 and a 25. I'm looking at extremes right now. Here's a 2 about right here. There's only one box plot that has a 2 and one box plot that has a 25. So this has got to be letter S. So S is off the list now. A 5 and a 23. Always look at your minimum and maximums. Here's a 5. It's going to be part of the data set, but it's not part of where the whisker goes to. Here's a 23. So this is set R or box R. Again, look at your ends, 10, 25. Okay, so I look at a 10, and maybe it's 1 or this one. I'm not quite sure which one it is, but let's look at this other number, 25 and 24. Okay, here's a 25. That's this one right here, and this one's short on to the 24. So this Q is my next one, and this T That's my last letter, is this one. Always look at your extreme values first. Indicate whether the distribution of the data appear to be skew left, skew right, or approximately symmetric or none. So let's answer that question first. So first of all, look at how, remember, this is the median right here. This value right here is the median. Well, if that's the median, this thing is being drug out to the right very far. I mean, it's going, look how far the tail goes over here. So this is definitely a skew right. Oops. Processing is what it says. Don't do that to me. I must have shortcut something. Skew right. Are there any outliers? Okay, no. How do I know there's no outliers? There's no asterisks, there's no stars, there's no anything like that indicating, because remember, the tail will not touch an outlier. Give a rough approximation for the mean. Okay, it's skew right, which means that the mean has been pulled this direction over here. The M here is the median. The mean is going to be somewhere in this box right here between these two. And since this is a 40, this is 80, I'm probably going to guess that roughly it's somewhere around 55 or 60. It's probably about here in the middle somewhere. So my best guesstimation is that the mean equals 55. And it could have been 60 and you'd have been just fine. It would not have gone above the 60 because 60 was in the middle here. The following describe the sample. It says the information given includes a 5-number summary, the sample size, and the largest and the smallest data values. So these are the 5-number summaries. Then it gives us a number of different tails, all of these data points right here. And it wants us to identify anything which is an outlier, and it wants us to use the IQR method. Okay. So let me get my paper warmed up. So what we're going to do is we're going to use that IQR method that comes from Q3 minus Q1. And I'm going to switch over to camera so we can do the math here. And I obviously have to have the data in front of me in order to do this. Okay, so the numbers that we have, first of all, let's do a Q1 and a Q3 value here. So our interquartile, right, so we have a 31. I got to go back and get them again. Hold on one second. I got a 31, 61, and 67. So we have a 31, 61, a 67. We have a 69 and an 88. We have a 69 and we have an 88. And those are listed in 5-number summary fashion. So right here is Q3 and Q1. If I take 69 minus 61, I'm getting the IQR right now. The IQR is 8. 1.5 times the IQR, because that's part of the formula, that's going to be 12. All of 8 plus half of 8, which is 4, and my IQR is 12. Now, what do I do with that actual IQR value? Remember, it's Q1 minus 12, and it's Q3 plus 12. Okay, for us, Q1 is 61. 61 minus 12, that's 59, that's 49. So my low right now, my lowest number that I can have is 49. Anything smaller than 49 is considered an outlier. Q3 is 69, and I'm going to add 12 to that, 69, 71, 81. Anything outside of 81 to the right is also going to be considered an outlier. So let's go to our list, and let's go find all the numbers which are smaller than 49 and at the same time bigger than 81. So first of all, boom, got one right there. 31. 31 is one. These are all okay because they're all good. And now we're working our way up. We want to be bigger than 81. So it looks like anything after here, 84, 85, 88. So really what we're doing is we're segmenting the list and saying you are outside of the range of the IQR times 1.5. The comparing statistics. For the measure of center, the mean is not resistant to an outlier. The median is resistant. So remember that in a box and whisker, the IQR is resistant because it's contained of nothing but medians. The measure of spread, we use a standard deviation, but it's not resistant. Why? Because it uses mean calculations. Remember, the standard deviation value uses that mean in order to calculate its values. The IQR is resistant, again, because of what I said. It uses Q3 minus Q1. The range is not resistant because it's outside of the medians. It says right here, we most often use the mean and the standard deviation. So guess what? The thing that we use the most is the thing that's most affected by things because they are calculated based on all the data values. So we use all of the available information. We don't like to throw away data as statisticians. We like to keep as much as we possibly can. A summary of one quantitative is that the center comes from the mean and the median. The spread is a standard deviation and an IQR along with a range. So that's your 5-number summary and your standard deviation. We use percentiles in order to gauge where numbers are in a quantitative relationship. And the 5-number summary is your best source for getting all this information. You visualize it using the dot plot, the histogram, and the box plot. Remember that stat key is your friend. If you go to the one quantitative, one categorical, you will see that here is the dot plot, the histogram, the box plot, all those things. You can always tell what your data is from just going there. Other concepts are the shape and the symmetry. Remember, it's skew based on outliers. Outlier data pulls your data towards the skew direction. When we talk about outliers, some are resistant and some are not. Depends. And the z-score is a calculation that you need to know where you take x minus x bar and you divide the entire thing by the standard deviation. Remember, when you do a z-score, you're really normalizing yourself against a standard scale from the mean plus or minus 2 z-scores for the 95% population. When we talk about the quantitative and the categorical relationships, remember, it's the 5-number summary that gets the job done. Now, when we look at the visualization, which we already did today, we looked at side-by-side box plots. If we went back up here, this was a nice calculation, a comparison between categorical groups. We were category Q, R, S, and T were the categories, and the quantitative data was right here in the box plots. So this is a quantitative categorical relationship. Got to go back to where I was. And these box plots can be either vertical or they can be side by side. So there goes a question that we're going to talk about. We have tea and immune, and remember we had this discussion previously. Participants were randomized to drink 5 or 6 cups of tea and coffee every day for 2 weeks. Both drinks have caffeine, but one tea has L-theanine. After 2 weeks, blood samples were exposed to antigens and produced interferon gamma, which is immune system response, was a measurement. The explanatory variable. So what would the explanatory variable of this particular item be? Well, it's going to be drinking 5 to 6 cups. Oops, can't spell again, right? Type, sorry. 5 to 6 cups of either coffee or tea. Because remember, we want to have a comparison group. And we'll go slash T. And what would the response be? Well, that would be the production of interferon gamma, right? So it would be the actual production. Terrible, isn't it, to watch somebody type? Production and actually the measurement of, and I'm just going to use interferon gamma. And let's put measurement production. Okay. Now, what are we actually going to do here? So If the tea drinkers have significantly higher levels, because remember, we need to find significance between the two groups, of interferon gamma, we can conclude that tea rather than coffee caused an increase in this aspect of immune response. And it's asking us, yes or no? Well, the answer would be yes. Why would it be yes? Well, it'd be yes because remember, this was an experiment that was being conducted. And if we have significantly higher differences between these two, then we can make a conclusion that we could have causality. We're not actually doing the calculations, we're just discussing what happens. So again, a revisit to the explanatory, what happens first, the response, the measurement we're getting. Was it an experiment? Yes, it was an experiment, and we have a control group. So if we have significance, we can have causality. Now let's look at those actual statistics that popped up here between these two. And this was all run for us in StatKey. So in tea, the mean was 34.8. Notice that the mean in coffee was 17.7, nearly double the value of mean in tea. Now this is for the production of the interferon gamma. Standard error was 6.35, where the standard error was 5.27. The data was farther spread out for tea. The data was more compact for coffee. The median was 47, whereas the median was 15. Now, what I would have you also notice on here is that 47 and 34 and 15 and 17, the mean was closer to the median for the coffee, so the data would not have been as skew, but the data was more in a skew direction here, but it also had a larger standard deviation or standard error. The standard deviation was 21, the standard deviation was 16, and the counts were very equal. Give the notation for and find the difference in means. Okay, so I'm going to go to my writing tablet for this because this will be easier for me to actually write out for you. So first of all, we're talking about mean values here. So let's talk mean of T. The mean of T was 34.82. The mean value for coffee was 17.7. So, and it says, let's go back, let me get the question. Give notation and find the difference in means. Okay, well, first of all, it didn't say for coffee versus tea or tea versus coffee. So there are two plausible ways for me to do this. My first way is to say that the mean of tea minus or the difference in coffee. So you could say that one minus the other, or the difference in tea compared to coffee would be, and if I did the subtraction work over here, would be 17.12. That's the difference in the two means. I also could say that the difference in coffee compared to the difference in tea, and you'll notice we're going to get a completely different number, which is negative 17.2. Now, here's what that tells me if you go back to what we've talked about before. If you put tea before coffee, you're saying that tea had a 17.12 higher instance of production of the interferon gammons. If you put coffee before tea, you're saying that coffee had a lower value of 17. Sorry, that's 1, 2 still. It didn't change. Had a lower value of 17.12 when compared to tea. So it matters how you write it and how you say it when you write this. Both are correct since the order is not designated. Now, that's a pretty decent number, 17.2. What does that mean when we look at this? Well, if you look at these two, look at the coffee and look at the tea, and all those things that we just talked about were pretty accurate. Remember, I told you that the tea should be more spread out. We can see that tea is more spread out. But yet at the same time, look at the percentiles and look at the IQR specifically. The entire IQR of tea is nearly above the production of coffee, meaning that 50% inside from here, because remember, because this box contains 50% from here to here, nearly 50% of that data value is above this, and an additional 25%. So nearly 75% of the data inside the T, because of here, 25, 25, 25, is above the median for coffee. So it gives us some clear indication when we're visually looking at it that the data block is much greater in tea than it is in coffee. I think I'll let you do this one. All it does is talk about, again, about regions and physical activity. Actually, we could actually do it. It's not that bad. It won't take too long. So the variables in the USS states includes percentage of people in the states who say they have engaged in at least 150 minutes of physical activity each week. So they give us Midwest, Northeast, South, and West. One of these variables is quantitative and one of them is categorical. Okay, so first of all, these are the categories right here, the region, and these are the quantitative, the minutes of physical activity. And the figures below allow us to visualize the relationship between the two variables, because that's what we would use. And because we're doing multiple categories, we use side-by-side box plots. Which region shows the lowest physical activity, which shows the highest? Okay, well, look for the box that's the lowest and look for the box that's the highest. The South is the lowest, and the West is the highest. South is the lowest, and the West is the highest. Are there any outlier data? No, there's no. Look for asterisks. If you don't see any asterisks, then the answer is no. No outliers. Does there appear to be an association? Now, this is a word which is much different than causation, right? Association. Does it appear that something is trending? That's what you can think about between the amount of activity and the region of the country. Okay, so take a look. First of all, let's just compare the South and the West right here. Almost the entire box and whisker plot is above. If I were to draw like a little line, if I kind of could, almost the entire box of the West is above that of the South. Does it appear that where you live affects how much you exercise? Sure does. It looks that way. Now, why? Have no idea. Remember, we're not looking for that. All we're looking to say is there an association? And the answer to this would be absolutely positively yes. Yes, almost almost all West, we'll go with West values are above the South values. You could expand on that a little further. Summary 1 for quantitative and 1 categorical. So the summary statistic is any summary statistic for a quantitative variable is broken down into a group. So we're breaking this down because we have the quantitative and the categorical together. We look at the difference in means because the mean is the calculation which is referred to when we talk about quantitative variables. We use a side-by-side box plot and a side-by-side dot plot. Most of the day today was spent looking at side-by-side box plots because they do give a little bit better understanding of the breakdown in the data, the 5-number summary, and the spread of the data. That's for 2.4. When we come back, we are going to get busy in 2 quantitative variables and talk about correlations, coefficients. Exciting times coming.